CRISP DM, or Cross-Industry Standard Process for data mining, is a process of 6 distinct phases. The first phase is business understanding, in which the analyst learns what the specific business goals of a data mining project are. The second phase is data understanding, in which the analyst gains an in-depth understanding of the data to be collected and used. The third phase is data preparation, in which the analyst may create a sampling or subset of the data, clean it, merge data sets, derive new columns from existing ones, or perhaps delete unneeded columns. The fourth phase is modeling, in which the analyst constructs models that provide business insights per the goals in the first phase. The fifth phase is evaluation, in which the analyst determines how well the outputs of the models deliver the desired business insights. The last phase is deployment, in which the analyst monitors the performance of the model and maintains it as needed to continue to provide value. What does time series analysis involve? In order to forecast from time series data, the data must have a constant mean, variance, and autocorrelation. In other words, the data must be stationary. If any of these metrics are not constant over the time span of the data, there are methods an analyst may use in an attempt to transform the data into a stationary time series. With the data stationary, the analyst may then apply ARIMA modeling or some other model to forecast future values. Regarding data ethics, the main principles of data ethics hold that individuals own their own personal data. This means that personal data should not be used or shared without the owner's consent. It also means that individuals should have visibility into how their data is being used, who is using it, and any transaction, that is, any sale and purchase of their data. This is known as transparency. There is also the matter of privacy that requires reasonable protections be implemented to protect the privacy of individuals whose personal data is being collected and used. Organizations that collect and use personal data should establish clear policies for the ethical handling of that data and require all those who have access to personal data to undergo training and periodic refresher training on those policies. In regards to measurement bias, first, the source of bias must be identified, as it could come from the algorithm on which the model is based, or it could come from the data fed into the model. In the case of the model, the underlying algorithm could be analyzed and modified, or completely replaced. In the case of biased data, the bias could come from the method of population sampling, the tools and instruments used to collect the data, or the way the data was processed after collection. Avoiding measurement bias can be done by establishing a team to continuously oversee the deployment of the predictive model and the data fed into it. It would also help combat bias if the oversight team is comprised of diverse people from different cultural, professional, and organizational backgrounds. Now about the difference between regression and classification models used in predictive analysis. Regression models and classification models are both used in supervised machine learning, but where the response of a regression model takes the form of a mathematically calculated continuous quantity, such as weight, length, or price, the response of a classification model is a categorical variable, determined by a decision tree. Examples of a categorical variable include film genres, country of origin, and transportation types.